So this is the second of 3 short videos on blockchain technology. They're short and high level in nature, but if you're interested in finding out more, check out the links at the end of each video. Smart contracts are agreements that have been written into computer code which automatically self-execute based on their terms. Often the terms are drafted as an if-then conditional. If this happens, this input is received, then do this output. You can set up a blockchain network so that essentially the code, the computer code which underpins a smart contract is published to the blockchain network, is deployed on the network, and you can then send transactions to that smart contract which will then self-execute in accordance with its terms. And because it's deployed on the blockchain, there's no central authority in charge of it. It automatically executes when it receives the right inputs, and it can't be changed, it's immutable. And often smart contracts rely on third-party systems consulted for information and relied upon for informational data, and they're called oracles. So let's look at how it works in practice in a bit more detail to just bring it to life. So the parties to a smart contract may create the terms and then convert that into computer code. That code then gets put together into a transaction, gets published to the blockchain, gets verified and validated in accordance with the consensus algorithm, and then gets deployed onto the blockchain network. So you have a smart contract deployed on the blockchain. It has a public key issued to it, identifying its location on the network, and a private key as well. And then the smart contract will self-execute in accordance with its terms, either when a transactional message is sent to it from the person that holds the private key, or on the satisfaction of certain external events which are triggered by information being sent to it by an oracle. Again, a third-party system consulted for information relied upon by the smart contract. And once that smart contract self-executes, that transaction is then recorded on the blockchain for everyone to see. Here we've got a private blockchain network between some parties. The main parties here are X and Y, and it's basically facilitating the transfer of excess energy from X, who has the excess energy, to a user Y that has an energy shortfall. And the smart contract's being deployed on that private blockchain based on if-then conditionals. If this happens, then transfer the energy from X to Y. And the if is based on 3 inputs. If X has energy surplus, and if Y has energy shortfall and pays for that energy shortfall at a given price written into the computer code, then self-execute and do the output, X transfer the energy to Y. And this assumes that the actual transfer of the energy takes place off-chain, outside the blockchain network, but it's actually the actual fact that's happened is recorded onto the blockchain network. And so in that example, the ifs, based on the 3 kind of inputs, are relying on oracles, external and third-party systems. So the information saying that X has energy surplus and Y has energy shortfalls based on a smart meter installed in their homes, which sends information to the smart contract. So energy excess, energy surplus, and then the final oracle could be a bank, which sends information to an API to the smart contract, telling the smart contract when Y is actually paid for the energy. And once all those 3 bits of input are satisfied, the energy gets transferred and gets recorded onto the blockchain network.